but we're going to look at some things that are a little bit higher in degree, a little bit more complex, and things of that nature. So some of this should look familiar, so some of it will look a little different. Okay, so here's a nice big old long expression to start with. Very similar to what I was asking you to do in the warm-up. We have 8x cubed times 2x plus 1 plus 3x times 2x plus 1 minus 3x times 2x plus 1 plus 2x plus 1. Now, anytime you're given an expression, the very first question you should ask yourself, regardless of what they're asking you to do, is can I simplify this expression in any way? Not necessarily, can I do any math to it, but can I simplify it? Is there anything that cancels? Is there anything that combines that would make this a simpler expression? The reason why I'm mentioning that right now is because we can make this a much simpler expression, right? Because what do we have right there in the middle? We have positive 3x times 2x minus 1 and negative 3x times 2x plus 1. The exact same expressions, opposite signs, so that means they're going to cancel each other out. So really we can just mark that stuff in the middle, mark it out. After I made you write it down, now I'm going to make you mark it out. All right, so let's look at what we've got left. Okay, what we have left is 8x cubed times 2x plus 1 plus 2x plus 1. So again, we've got that binomial, two terms, 2x plus 1. We have that in common, so we're going to factor that out. We are left with 8x cubed. And again, don't forget, you got to put a plus 1 over there for that last term. I suggest putting any time you have something like that, put a 1 in front of it. Just it's an extra reminder. And guess what? We can take this a step further. 8x cubed plus 1 is the sum of perfect cubes. Bless you. So let's factor. We're going to have a binomial times a trinomial. The cube root of 8 is 2. Cube root of x cubed is x. Cube root of 1 is 1. 1 is its own square root, cube root, fourth root, square, cube, everything. 1 is just that amazing little number that does everything. Okay, squared the 2x, 4x squared. Multiply the 2x and the 1 by each other, 2x. Square the 1. 1 squared is 1. So, same. We started with a plus up there, so it's the same sign, positive, opposite, so it's negative, and the last sign is always positive. Now, there's one more thing this isn't factoring. We're finished factoring, okay? Those trinomials on perfect cubes will always look like they'll factor further, and they're really close, but they will never factor further. Okay? Anytime you factor perfect cubes, you're done. Okay, there's no more factoring to be done. But there is another way that we can write this. We have the same expression right there multiplied by itself. So a simpler way of writing it would be 2x plus 1 squared, because we have it times itself, that's squared, times the 4x squared minus 2x plus 1. Now, if you were to run into that, on something that I'm grading, probably not going to get real nitpicky about making you write it as squared, but I do want to show that to you because as a multiple choice answer choice, it's going to show up as that expression squared. It's not going to have it written twice. Okay, so just something to be aware of. Okay, now let's look at the next example. 15x cubed plus 18x squared plus 20x plus 24. All right, so this one's a little different. We always look for GCF, right? So variables are easy to pick out. We've got x cubed, x squared, x, but the last term doesn't have a variable. So No GCF of x. In terms of our numbers, 15, 18, 20, and 24, well, 3 of them are divisible by 3, but 20 is not divisible by 3. So no GCF for the entire expression. And we have 4 terms. We're not used to having 4 terms when it comes to factoring. And we have x cubed. The only thing that we factored with x cubed is if there's a GCF or if it's the difference or sum of perfect cubes. Well, that only has 2 terms. We've got 4 terms. So this is a different method called grouping. You probably did this in Math 3, but let me jog your memory. Okay, this is factoring by grouping. You're going to group the first 2 terms together, and you're going to group the second 2 terms together. Now you're going to analyze those pairs separately for their own GCFs. So between 15x cubed and 18x squared, they're divisible by 3, and they both at least have x squared. So when we take out that 3x squared, we're left with 5x plus 6. Okay. Now we're going to look at the 20x and the 24. Their greatest common factor would be 4 and no variable. So when we take that out, we get 5x plus 6. So notice, now they have something in common. They both have 5x plus 6 as a factor. That is what should happen. When you factor by grouping, you should always get the same binomial. Okay, you should always get that same expression right there. So now it's just like A. They both have 5x plus 6 in them, so we're going to factor that out. And we are left with 3x squared plus 4. Before you box in your answer, you want to look at that and say, do I have the difference of perfect squares? Well, no, because there's a plus sign there. But you should always check and see if you can factor anything further. And remember, you can always check your factoring by multiplying it back out. So I'm going to do that over here to this side just to make sure. So it's just a binomial times binomial. That means I'm foiling. 5x times 3x is 15x cubed. 5x times 4 is 20x. 6 times 3x squared is 18x squared, and 6 times 4 is 24. It's in a different order. Those middle 2 terms are switched around, but it's the same expression. Okay? So I encourage you to do that. Okay? Multiply it out. Make sure that it does give you that original polynomial. Okay? Let's look at a couple more. 56n cubed plus 24n squared minus 35n minus 15. Again, 4 terms, highest degree is 3, probably factoring by grouping. So pair the first 2, pair the last 2. 56 and 24, divisible by 8. N cubed, n squared. So we take out an n squared. So we are left with 7n plus 3. Last pair, anytime that first term in that second pair is negative, you got to take out the negative. 35 and 15, we've got a GCF of 5. So what are we left with? 7n plus 3. If you didn't take out the negative, you should catch it when your factors there don't match up exactly. So take out the common factor, 7n plus 3, left with 8n squared minus 5. I feel pretty confident in that, so I'm not going to go through and check it, but you, of course, can. Questions so far? Okay, last 2. 9n cubed plus 12n squared minus 15n minus 20. You should still always look over it to make sure that there's not a GCF for the entire expression. So 9, 12, 15, looking like 3, but 20 is not divisible by 3. So nothing there. Pair them up. 9n cubed plus 12n squared, GCF of 3n squared. So we're left with 3n plus 4. GCF the second pair, negative 5. So we're left with 3n plus 4. Negative 5 times positive 4 is negative 20. Take out that GCF of 3n plus 4. We are left with 3n squared minus 5. It's the difference of squares, but they're not perfect squares. 3 and 5 are not perfect squares. So we're done with that. All right, last one. 8x cubed plus 3x squared minus 8x minus 3. 8 and 3. Do they have anything in common? Do they have a common factor? Bless you. Other than 1? No, they don't. So all we can take out here is x squared. Left with 8x plus 3. Same thing with the second pair. Negative 8, negative 3, nothing in common other than we got to take out that negative. So that's 8x plus 3. So common factor comes out, 8x plus 3. We are left with x squared minus 1. X squared minus 1, difference perfect square. So we can take this one just a step further. X plus 1 times x minus 1.